At its heart, Terzaghi's 1D consolidation theory describes the process by which soils, specifically fine-grained clays, decrease in volume over time under an applied load. Imagine a saturated sponge soaked in water and placed inside a metal cylinder. When you press down on that sponge, the water can't escape instantly. It takes time to flow out of the tiny pores. In soil, this pore water pressure initially carries the entire load. As the water slowly drains away, the stress is transferred to the soil skeleton itself, leading to settlement. A breakthrough in the lab. The history of this theory is rooted in Terzaghi's relentless experimentation during his time at Robert College in Istanbul and later at MIT. He realized that the rate of settlement wasn't just about the weight of the building, but the permeability of the clay. He developed the oedometer test, a lab procedure that mimics a building's load on a soil sample. By measuring how fast water escaped, he could finally predict whether a foundation would settle an inch or a foot, and whether that process would take 2 years or 2 decades. The mathematical foundation. To quantify this phenomenon, Terzaghi developed a partial differential equation that relates pore pressure, time, and depth. In U.S. customary units, the governing equation is typically expressed as shown. In this formula, U represents the excess pore water pressure, pounds per square foot, T is the time, days or years, and Z is the depth, feet. The magic variable here is C_V, the coefficient of consolidation, measured in feet squared per day or feet squared per year. This value tells us exactly how leaky the soil is and dictates the pace of the entire settlement process. Calculating the settlement. When engineers need to know the total magnitude of the squeeze, they look at the primary consolidation settlement, SC. Using US units, the simplified formula for a normally consolidated soil is as shown, where H is the thickness of the clay layer, feet, E sub 0 is the initial void ratio, C sub C is the compression index, sigma prime sub 0 is the initial effective stress, pounds per square foot, and delta sigma is the new load from the structure. This equation allows us to move from abstract physics to concrete engineering reality, a legacy set in stone and clay. Terzaghi's 1D theory remains the industry standard because of its elegant balance of complexity and utility. While we now have advanced computer modeling and 3D analysis, his one-dimensional approach, assuming water mostly moves vertically, is still the first calculation every geotechnical engineer performs. He didn't just give us formulas, he gave us the ability to build skyscrapers and bridges on weak ground with absolute confidence. Every stable foundation in a coastal city today is in some way a monument to Terzaghi's genius.